Good morning, Science 20s. Our lesson today is actually a little bit more difficult. What we're going to do is we're going to break it into two parts. In part one, we're going to talk simply about the definition of oxidation and reduction. We're going to look at easy ways to determine if something is going through oxidation or if something is going through reduction. In part two, we're going to take these ideas and combine them together to discuss and figure out what a redox reaction is. So let's get started. So the definition of oxidation is a chemical process involving the loss of electrons. And this is going to be the key to this loss of electrons. If you are losing electrons in a chemical reaction, that means the reactions is going to have the electrons on the right-hand side. The electrons will be leaving the reaction. So when we write out a reaction here, to the right of the arrow is going to be where we see the electrons. The electrons are going to be leaving. Loss of electrons, oxidation. In a reduction reaction, the opposite is going to be true. This is where we're going to see a gain of electrons, which means the electrons are going into the reaction. We're going to see them on the left-hand side of the equation. So when we gain electrons, electrons are on the left. They are going into the reaction. When we lose electrons, electrons will be leaving the reaction on the right. Now, I want to look at this in terms of a number line. So let's look at a neutral substance. So we're going to put a nice balance of positives and negatives here. So this has a charge of 0. Positive, negative, positive, negative. They cancel each other out. Okay? Now, the definition of reduction says involves a gain of electrons. Well, since electrons are negatively charged, E minus, if we gain some negative electrons in this example, you will notice that this is going to now have an overall negative charge. Notice we're moving this way. When we gain electrons, that is what reduction is. We're going to have negative charges. When we lose electrons, and the easiest way to lose electrons is, let's make them disappear, so we'll just cross them out. Notice what now happens. When we lose negative electrons, my substance now becomes more positive, which means I'm moving to the right. If I am more positive, I am going through oxidation. That's when I lose negative electrons, I become more positive. And when I gain negative electrons, I go through reduction. I'm gaining more negatives. This whole lesson is about electrons. That's the only thing that can move. Now, this should make sense because if you think about an atom, safely in the nucleus of the atom is where we put protons and neutrons. They don't have an effect. However, out here in these shells and these orbitals, these are where my negative electrons are. And my negative electrons can leave, or they can gain more, or they can even share electrons in a molecular compounds. It's the electrons that are always moving. That's why this electrochemistry is so important, because it has to deal with movement of electrons. Well, an easy way for us to think about this is to think of the idea of Leo the lion says grr. This is an easy way for us to remember it. Leo stands for losing electrons is oxidation. Gr stands for gaining electrons is reduction. So every time we are losing electrons, we are going through oxidation. Every time we are gaining electrons, we are going through reduction. Leo the lion says Gr. So let's take a look at this first example. I have lithium atom going to lithium ion plus an electron. Notice, an electron is leaving the reaction. Therefore, losing electrons. This example is going to be, oops, let's go back. I need a pen. This example is going to be oxidation. I know it's oxidation because remember, Leo, it's losing electrons. Same with this half reaction. Aluminum atom is going to aluminum ion. Ions contain a charge. So since my electrons are on the right-hand side, they are leaving the reaction. Losing electrons means this is oxidation. Well, all four of these are going to be oxidation. These are all going to be the same examples. So let's show how we can do these two by using our data booklet. So in your data booklet, I would like you to find cadmium. Cadmium is element number 48. So we have cadmium CD. And if you look, the charge on cadmium is 2 positive. And anytime we write something with a charge, we call it aqueous. Ions are always aqueous. So how do I write this out in a half reaction properly? Well, first we balance atoms. 1 cadmium atom on the left, 1 cadmium ion on the right. 1 to 1, that's balance. Once we balance the atoms, now we have to balance the charges. Well, since this is an atom, it has a charge of 0. There is no charge. Well, this is an ion and it has a charge of 2 positive. Well, this has to add up to equal 0 on the left-hand side. So 2 positive plus 2 negative electrons. So 2 positive plus 2 negative equals 0. 0 on the left, 0 on the right. Remember, the only thing I can add is electrons because that's the definition of electrochemistry. Adding of electrons or losing of electrons. So again, since these electrons are on the right-hand side, they're leaving. Therefore, this is an oxidation half reaction. Let's try one more example. Br minus. So find Br on your periodic table. You will notice that it's element number 35. And I got my periodic table here. So it's right here. It's element number 35. Okay. Now, if you look, we have Br minus. We have the ion form of this. So we're going to copy out the atom. Now, this is a little tricky because Br is one of my specialty cases. So you will see that Br is actually on my list over here, and it tells me that Br on my polyatomics, that's Hofbrinkel the clown, that is supposed to be written as Br2. So when I write this down, I'm going to write this as Br2. So like we did for cadmium, we balance atoms first. So I have 2 bromines, and this is a liquid. So I have 2 bromines on the right, and so I only have 1 bromine on the left. So the first thing I'm going to do is put a 2. 2 bromines on the right, 2 bromines on the left. Now my bromines are balanced. After I balance atoms, I then have to balance charges. So 2 negative on the left-hand side, no charge on the right-hand side. Well, since I'm only allowed to add negative electrons, 2 negative on the left, 2 negative on the right. 2 negative, 2 negative. They're going to equal each other. And again, it's losing electrons because these are 4 examples of oxidation. Okay, let's try a different example. So we're going to go to red here. This guy has now my electrons on the left and my electrons on the left. Well, if electrons are on the left, these are going to be reduction half reactions because reduction is the gain of electrons, GERD. So iron ion plus 2 electrons, gaining 2 electrons will make iron. Let's make sure this is balanced. 1 Fe on the right, 1 Fe on the left. 2 positive plus 2 negative, no charge on the left, no charge on the right. Let's look at the second example. 2Cl, 2Cl. So 2 chlorines, 2 chlorines. 2 negative charge, 2 negative charge. So 2 negative charge on the left, 2 negative charge on the right. It balances. We balance atoms first, then we do ions. So let's go in our data booklet and find Au. So Au is element number 79, and we already have it written as an ion with a charge. So the atom is just Au solid. So we have 1 Au on the right, 1 Au on the left. Balance atoms first. Now we're going to balance charges. 3 positive on the left, no charges on the right. So 3 positive plus what gets me no charges? Well, that's going to be 3 negative electrons. 3 positive plus 3 negative, no charge, no charge. Well, this is perfect because my electrons are on the left. This is a reduction half reaction. We are gaining electrons for reduction. So all my electrons will be on the left-hand side. Again, let's do nitrogen. Find N on your periodic table. Nitrogen looks like it's element number 7. So we're going to copy it out. The charge on nitrogen is 3 minus. And since it's an ion, it's got a charge. We're going to write aqueous. So we balance atoms first. We have 2 nitrogen. We only have 1 nitrogen. So we're going to have to put a 2 here. 2 nitrogen, 2 nitrogen. We have 6 negative. N3 minus plus N3 minus is 6 negative. So we're going to need 6 electrons. Again, since the electrons are on the left-hand side, we are gaining electrons. Gaining electrons is called reduction. Leo the lion says grr. Okay, let's clear this. And let's go to our last page here and try to figure this out. So when we're trying to figure this out, we're going to make a decision. Is this oxidation or is this reduction? So let's get a pen color here. We'll go back to blue. Cu2, okay, the electrons are on the left. So let's write something down. Leo the lion says grr. So we are on the left-hand side gaining the electrons. If we are gaining electrons, that makes this reduction. Let's look at the second example. Pb2 positive plus 2 electrons. Again, we are gaining electrons. Gaining electrons will be reduction. Let's do our third example. Chromium goes to Cr2 positive plus 2 electrons. Well, notice in this example, our electrons are on the right-hand side. They are leaving the reaction. Leaving electrons is going to be oxidation. Now, these two examples are a little bit harder because they're not written out for us, so we have to do that. Let's look for Sn. Let's look for tin in our periodic table. It's element number 50. So we know by looking up, we'll just take the most common charge. It goes to Sn for positive aqueous. 1 Sn, 1 Sn, no charge. 4 positive plus 4 negative electrons. 4 positive plus 4 negative, no charge, no charge. In this example, since we are losing electrons, they're leaving the reaction, this is going to be oxidation. We have one example left. We have Ni2 positive. So let's look for that in the periodic table. That's element number 28. It's going to go then to nickel. So Ni2 positive charged nickel goes to nickel atom. 1 Ni, 1 Ni. So the atom is balanced. Now let's balance charges. No charges on nickel atom. 2 positive on nickel ion. So 2 positive plus 2 negative equals no charge, no charge. Since this one is gaining electrons, electrons are on the reactant side, it is getting electrons in this reaction. This one will also be a reduction half reaction.